Hey guys, I'm sorry I cannot be with you today. I wasn't planning on being gone, but I had a meeting scheduled for the morning, and then with the change of the bell schedules, it made me miss third period too. So sorry I'm missing you. Today's lesson is actually pretty quick. Should have time to work on homework in class, which I know is amazing. So one quick announcement, just want to point out here. So after school today, your MC from our test on Wednesday will unlock. You can see your scores, see what you missed, and start working on corrections. We're going to have till December 5th for those retakes, and then I'll have your FRQs for you next week. But if you wanted to start working on that process, get a head start, it will be ready for you, okay? Make sure you've grabbed a green note packet and assignment packet for Unit 4, okay? All right, so Unit 4 is chemical reactions is our overall theme. So we're going to kind of review one topic here that we've kind of hit before about matter, and then connect it to chemical and physical properties. So that's our first one here. 4.1 is identifying evidence of chemical and physical changes in matter. Okay, so we talked about matter back when we did our separating lab. Our first lab we did with the dirt, alcohol, sand, iron filings, all those things mixed together, right? So let's look at these pictures here to kind of just connect once again what we see with our eyes versus what is happening at the molecular level. So I'm going to start here with the first two. The first ones I've done for you just to kind of get us started. So the second one here would also be a gas because gas molecules are not connected and they're spread out from each other. Okay. In terms of what it is, I noticed that there's two blue ones. Okay. And then different, there's a blue with an orange, which means these are not the same thing. The blue one would be an element. The blue with orange would be classified as a compound. And so we would call this all together an element and compound mixture because you got both of them going on. So element is just the same thing bonded to itself or singular, and then a compound is two different elements bonded. I'm not quite sure how this printed in your note packet, so you may want to add some coloring so that you can distinguish the differences in the circles. Okay? All right, I'll do one more with you, and then I'll have you try the last ones for some smiley faces. Okay, so this one is actually going to be the same answer as before. We have an element, our singular blue circles, right? And then we have a compound, and then they're together, and so we call it a mixture. All right, so there's our compound. Okay, oh, and this would be a gas because they're spread out from each other, not touching, no IMFs happening here. Okay. All right, go ahead and pause the video for, let's go 2 minutes about, and then hit play and check your answers. All right, so this first one here, you should have just compound. Okay, and this is still a gas. Have a smiley face if you got those right. Okay. Next one here would be just element, and it is in a liquid state. Have another smiley face if you got those right. And this last one here we would call an element mixture, or maybe a mixture of elements, and they are in a gas state. Okay? If you got any of those wrong, don't understand why, ask your neighbor, ask a table next to you, make a note and bring it up next time to me, okay? All right, the next thing here is chemical versus physical changes. What we're going to do with these boxes is I was going to do some demonstrations, so I'm going to do those next time still. So go ahead and skip this section here, and let's just come here to where it kind of talks about the difference. So the key thing is a physical change happens when it undergoes just a change in property, but not what it is. Okay, my best example are changes of phases. So going from a solid liquid to a gas doesn't change it, right? If I have water, that's an ice. We would write it as H2O with a little S by it. That means it's a solid. And then if it melts, we would write it as H2O with a little cursive L, which means it's a liquid, right? But the bonding hasn't changed. The only thing that's involved is just a breaking of our intermolecular forces. On the other side, a chemical change occurs because they are actually changing their bonding. Okay, key thing here is chemical bonds are being broken, new bonds are being formed. It's not the same thing, I think of once again, as the Legos are rearranging. Some things we often see as this is happening, because energy is part of the process, is we can see heat, light, a gas gets created, meaning something new. We're going to talk about precipitants in this unit. Color change, and with color change, I'd kind of say like unexpected color changes. So those are our chemical changes, okay? In terms of a chemical formula, we would see possibly like H2 plus O2 can react with each other and make water, right? So a new substance is made. This is a gas. This is a gas, right? This is a liquid. Their properties are completely different from one another in what they do, right? We need to breathe this in. We can't breathe in water, right? This is explosive. Both of these are. And this puts out explosives, right? So key thing is properties, chemical and physical change when something undergoes a chemical reaction, okay? All right, our next objective, quick question. Turn to your table, buddy, and answer this question. Do you think is 2H2O the same as H4O2? And justify your choice. Okay, I'll give you 1 minute. Talk that over with your table buddy, see what you think. All right, I'm not really sure if that was a minute. I was kind of just counting in my head, but hopefully you've had a chance to discuss. The correct answer is no, they are not the same. There's a difference between what a number in front and small numbers down below means. So let's discuss that. Okay, so our next objective is all about understanding the parts of a chemical reaction and then learning what it means to be balanced. So one fundamental law of science is the law of conservation of mass. It says mass is neither created nor destroyed in a chemical reaction. The atoms are simply rearranged, but the total mass stays the same, right? So things can change, they can reconnect, but the number of Legos you have on the left side of the arrow must equal the same number of Legos on the right side of the arrow, okay? Now, the cool thing about atoms and chemical reactions is as long as you have enough of both things, right? So we look at our boxes here, right? So as long as there's enough hydrogen and enough oxygen, they'll react. It doesn't have to be perfect, right? Like in actual baking, you have to be so particular about the ratios you use of flour to sugar to butter and all the things, right? Otherwise, you'll not make what you're planning on making. Chemicals, when you're just reacting like in these simple chemical reactions together, as long as you have, once again, enough, you can make what you want. Now, what I want to point out here, though, is you can have what is known as excess. So circle right here with me. Let's get something that'll stay, right? So this is what we would call excess, and in this case, H2, right? So it reacted, but in the way the ratio occurred, there was a leftover H2. So the way the ratio works is if we look at our final product here, right? Let's look at one water molecule. We need two H's with one O. So in a sense, one of these H2 breaks apart and pairs up with just one of the O. Well, you can't just have one of each because then you'd have a singular O left over, and O is not something that is ever by itself. So in order for this reaction to work, you need at least two H's or H2 molecules to go with an O2 molecule, and so our balanced equation is we need two of these for every one of these, And then in the end, it would make 2 water molecules, right? This is what we call our balanced chemical equation. It gives us the ratio of how it reacts. Now keep in mind, these numbers, 2, 1, 2, don't match what's in the boxes because the boxes can be whatever we choose to pour in and how much we get out. But it tells us the ratio of how they will bond with each other, okay? So let's define these different numbers here. So we have 2 key vocab. We have subscripts and coefficients. So the first number is, what is the subscript? So draw or get a highlighter for me, okay? And a subscript, oh, that's not going to stay. I'm going to do in red here. Subscripts are the small numbers that I'm circling right now. So highlight this word in red or pink, and then highlight those small numbers. Okay, this number indicates bonding. Okay, that they are chemically bonded, 2 H's, right? This is H2 as they're chemically bonded together. On the other side, I'm going to switch to blue here. A coefficient, circle this number, and this number, okay, tells us sets. So this means that we have 2 H2 molecules, right? So 2 H2 molecules. It talks about sets of them, but they're not connected, right? These are not connected to each other, right? Oops, this is an H2. This is an H2, but they're not connected, okay? So if you change the subscript, you change the substance, right? Like it's literally something new because of you're saying it's bonded. My favorite example of this is H2O is not the same as H2O2, right? They're made of hydrogen and oxygen, but those subscripts make a difference. This is water. This is hydrogen peroxide. Not the same thing. Okay? If you change the coefficients, then you're just changing the amount, which, once again, doesn't mean it will work, but you're not actually changing the chemical identity of it. Okay? All right, so this leads us to balancing. So one thing that we need to do is when you look at a chemical equation is to understand that ratio, right? That we saw back in our water of like, okay, we're going to need 2 of these for every one of these to make it work. Okay? Here's the steps we can use to balance. They're really, once again, just to guide you if you get stuck in some hints. Really, it's just get it balanced. The number of things on the left have to equal the number of things on the right, atom by atom. Okay? But the things to consider is, number 1, we are only adding coefficients, never change subscripts, okay? Subscripts make it what it is, and you're changing the substance if you add a subscript, okay? Polyatomics, and I'll show you this, when we see them, group them. It makes it a lot easier, okay? And then sometimes you can get carried away, and you might end up with numbers of like 4, 2, 4. If you notice that, reduce it down to 2, 1, 2, okay? Because a balanced equation should be the lowest possible ratio. And then really, in a sense, you can check your answer because the answer is it should be balanced, right? If there's 2 NAs on the left side of the arrow, well, then you should have 2 NAs on the right side of the arrow, okay? All right. This first problem, I'm going to just show you a visual way of looking at it. You can use this method all the time for balancing if your brain takes it this way. I will say it takes a little bit longer than another way in which I keep track. But if it makes sense to you and it works, then you should do it. So what I'd like you to do is to grab 4 different colors. Okay, and we're going to pick a different color for each element in this and kind of draw a visual representation. So I'm going to do, for aluminum, I'm going to do pink. Okay, so for this AlCl3 molecule, let's see if I might make my dot here bigger. Okay, we have 1 Al, and I'm going to do yellow for Cl, with 3 Cl. So that's 3 yellow dots. Okay, notice I've kind of drawn them like connected. Oh, that's a bad line. Undo that. Go away. Okay, but I'm drawing them connected because it's a compound, right? And like they have to come as a set. Okay, all right, I'm going to do Na. Let's do orange. Do you have an orange highlighter? I don't think so. Let's try to pick what you have. I'm going to do green. Okay, so we have 2 NAs and a sulfur. I'll do blue. Okay. All right, let's draw it on the other side. So aluminum, we got 2 of those, and then 3 sulfurs, which for me was blue. Okay, and then we got an Na, which was green, and a chlorine, which is yellow. My dots are getting bigger as I go. All right, so starting with, I'm kind of drawing a visual representation to see what's on the left and what's on the right. I'm going to draw a little squiggly line here just to help us really see that line. Okay, give you a second to get those dots made. So our goal is to understand how many on the left, the number on the left needs to equal the number on the right. And this will show us, in a sense, how they react and what ratio is created. So first step of balancing, or I guess second step of balancing, I don't know what step it is, but it's just focus on one at a time. Okay, don't try to fix all the problems at once, just fix one. So I look and I see, as I look at my colors, and I say, well, I can see that there are 2. I'm going to highlight my laser here. Right, I can see that there's 2 aluminums on the right and only 1 on the left. So that obviously wouldn't work out. So in order for this to occur, there must have been 2 of these to start with. Okay. Now, once again, keep in mind, when we balance it, we're not telling the reaction what to do. We're actually trying to understand what it will naturally do on its own. Okay. All right. So that means my pinks for now, I'll make a little code over here. My pinks are balanced. That's supposed to be a check mark. Check. Okay. All right, let's pick another color. Okay. Let's go with blues. Okay. So I can see that on the right side, I have 3 blues. On the left, I only have 1. So let's go ahead and balance that out. So let's add 2 more to make it 3. Now, once again, these things come as a group. So in order to add 2 blues, there have to be 2 more greens to come with it. Okay, so once again, I'm only really looking, I just look at one at a time. Blues are balanced. Okay, all right, let's pick another color here, and let's go with my greens I just added, right? I see that there's 2, 4, 6 on the left, and only 1 on the right. So let's add enough so that the sets are the same. So 1, 2, oh, whoops, that's disappearing. 1, 2, 3, 4, 5, 6, and then the yellow comes with it. Okay, so that's going to give it that my greens are now balanced. So the only color I haven't checked are yellows. So if we look here, this side has 3, 6, and this side has 6. So it turns out, without even thinking about it, the yellows have become balanced, which is normally how it happens. When you focus on just one at a time, it works itself out. Okay, so now we add our coefficients to represent how many sets we have. So we have 2 sets of these, 3 sets of this, 1 set of that, and 6 sets of these, and that's what we would call a balanced chemical equation. Now, just a minor note that writing the number 1 right here isn't necessary, because if you just, once again, have this, that means one of them. On the homework, just because how the computer's going to have to grade it, you'll put in 1s. But no, like on the AP test, if it was an FRQ, you wouldn't have to put it there. Okay? All right, let's try one without colors and just tracking our numbers. Okay? So, same concept, but it's a little bit faster if we just track numbers. So I like to write what I call my scoreboard in the middle of it. That kind of helps me see and keep track. Now, as you do this more and more, you might be able to just keep track in your head, and that's fine as long as you get them right. Okay, if you're not getting it right, then just write it out so you don't lose track. Okay, so to start off my scoreboard, I look on the left and I see 1 aluminum. So I'm going to put a 1 here. Okay, on the right, also 1 aluminum. Okay, so I'm going to add a 1 there. Okay, go to the next one in my scoreboard. Got copper, one on the left and one on the right. Finally, my chlorine, this one has 2 on the left because that's subscript. And this one has 3 because of that subscript. Okay? All right, so now let's start balancing. So the only thing not balanced right now is our chlorine, so let's get that fixed. So another trick with balancing you can use is if you kind of notice, right, that these two don't go into each other. And so if you think of least common multiple or kind of flipping them, right, is if I can get them both, right, to 6, then they would be equal. Okay, so to get 2 to 6, that means I need 3 sets of my Cl2. Okay, so I'm going to put a 3 up here on my line, and then I have to adjust my score. Okay, so the biggest thing with the scoreboard students mess up is don't change anything here until you put a number. So now that this number's here, that changes my copper to a 3 and my chlorines to a 6. And I actually prefer, even if I have a pencil, to use this like crossed off method because it helps me see like how it's progressing. Once again, it's just how I like to keep track. Okay, let's go to the other side, right? Since this was a 3, right? And I come up here, these come in sets of 3, right? Then I'm going to put a 2 on the line, okay? Then I look and say, okay, well, that's going to give me 2 aluminums and 6 chlorines. So we've fixed our chlorines. We've messed up the others, but that's sometimes how it goes. You fix one problem and make others. So let's fix, I'm going to come up to my aluminums and I'm going to fix that. Okay, there's 2 on the right, so I need to make sure there's 2 on the left. So if I just put a 2 here, since it's by itself, that is now fixed, 2 and 2. Okay, so let's fix our copper. There's 3 on the left, so let's put 3 here, because then that will change my score to 3. And now everyone is balanced, and I am done. This is our final balanced equation. All right, let's try one more together, and I'll show you that idea of grouping, and then I'll have you try some to practice, okay? So if you look at a balanced equation and you notice some of our polyatomic elements, which are our elements, once again, that exist as groups and stay as groups, then you can balance them as a group, okay? So the group I'm noticing here that stays together is SO4. Parentheses can be a big hint, right? Now, there aren't parentheses on this side because there's only one of them, but it's still a group. So when I'm making my scoreboard, I could count it as H, SO4, AL. Now, this other one here that's in parentheses, notice there's an OH on the left, but there's not an OH on the right, so I can't group that one. I'm going to just write O and H, which I already have in my list, as separate things. Okay? All right, let's make our score. Now, once again, you don't have to group. You could have separated the sulfur out, but grouping will make it go a lot faster and be less to keep track of. All right, so let's look at our hydrogens, right? So I'm noticing on the left that there's 2 here, and then there's actually 3 here. So that's going to give me a total of 5 H's on the left. Well, on the right, there's just 2. Okay, SO4, there's 1 of those as a group, and then there's 3 of them because we're grouping them, right? So we only look at that number outside the parenthesis. Aluminum, we got 1 and a 2. And then oxygen, since these oxygens were part of the group, I don't need to count them. So I'm just looking at this one. So this would mean there's 3 oxygens there and 1. All right, another hint I use is ignore the ones that seem hard, right? Particularly when you have elements in lots of places, H, H, H. That can make things complicated. So just ignore them and they'll take care of themselves, okay? This one doesn't look too bad, so let's do SO4. There's 3 on this side, so let's go ahead, and if I put a 3 in front here, then that will change my total. So let's adjust. So that's going to change my SO4 to 3, but it's also going to change my H's. Okay, so notice my H's, 3 times 2 would give me 6, but then I also have to add 3 from that one, and so we're looking at a total of 9 H's on the left. All right, these look good, so I'm going to move on. Let's go to aluminum. We got 2 on the right, so let's go ahead and get a 2 on the left. So remember, always play the game. Okay, once again, this is the game. Then update the score, right? This is the score. Don't do the score and then the game. Okay, all right, so putting a 2 there, that would give me 2 aluminums. So change that to a 2. Okay, it's going to change my oxygen to a 6. And then let's readjust our hydrogens again. Remember, we have 6. Whoops, didn't want to color there. We have 6 hydrogens here, and now we have 6 hydrogens there. So that would give us a total of 12 hydrogens. All right, we just fixed our aluminums. Those are good. Let's fix our oxygens. Okay, we got 6 on the left, so we need to make it so there's 6 on the right. So I'm going to play the game, put a 6 here. Okay, that will change my oxygens to 6. Okay, and then it's going to update our hydrogens. 6 times 2, oh wow, look at that. They've become 12. And so if I look at all my numbers, everything is beautifully balanced. So here's our final answer. 3261 would be what we call our balanced coefficients. All right, go ahead and hit pause on the video and go ahead and try these out. Maybe someone set a timer for like 5 minutes or so. And then after you've had a chance to try them, then hit play and you can check them for some smiley faces. You can work with each other on it. You can use either method. You could do the colored dots. I've had students do that before. Just grab the highlighters or track them by numbers. As long as it's balanced, doesn't matter how you get there. Okay? All right, hopefully that went pretty good for you. You should have for the first one, 2, 2, 3. Go ahead and give yourself a smiley face if you have that correct. Second one, you should have 2, 1, 2, 1. Have another smiley face there. And final one, you should have 2, 3, 2, 3. Okay. Homework tonight, we have homework 4.1, which is balancing practice. Okay, that one is in your packet, but you're going to submit it as a Canvas quiz. Okay, so once again, you don't have to do it on the paper, but it just kind of gives you a place to work it out. Okay, and then we also have a homework 4.4, which is just a Canvas quiz. And that is just some questions about identifying chemical versus physical changes. Okay, should be pretty quick, so I'd get started on them now, and you should be able to get a good amount done and not have too much homework. Okay, all right, good luck.